Welcome to this explainer. You know, we usually think of the human cell as this incredibly efficient, bustling microscopic factory, right? Materials are shipped in, they're processed, and then shipped out in this absolutely perfect rhythm. But what happens when that rhythm completely breaks down? What happens when this brilliant little factory turns into a microscopic hoarder, just totally unable to clear its own clutter? Well, today, we are unpacking the fascinating and honestly pretty destructive world of intracellular accumulations. Okay, let's quickly run through our agenda for today. First, when cells become hoarders. Second, the sugar stockpile. Third, tangled and twisted proteins. Fourth, fatal fat accumulations. Fifth, the color of disease. And finally, we'll wrap up with the big picture.
All right, Section 1, when cells become hoarders.
Internal trash buildup.
So what does this actually mean? Well, this accumulation happens when the cell's normal, perfectly balanced machinery for processing materials just flat out fails. We're essentially talking about a massive, microscopic traffic jam. The cell is either taking in way too much stuff, or actually, maybe its metabolic engine is broken and it can't process what it already has. Or the export doors are just jammed shut. The end result? A huge buildup of substances. And these can be normal everyday materials or completely abnormal ones, just shoved into the cytoplasm, the organelles, or even the nucleus itself. There are really four primary ways that normal, healthy cells get overwhelmed like this. First up is abnormal metabolism, where the cell just can't process standard nutrients properly. Second, we have mutations that cause proteins to misfold into these useless, tangled shapes. Third is a genetic lack of specific enzymes, which basically means the cell is missing the biochemical scissors it desperately needs to cut up complex molecules. And fourth, the cell simply ingests exogenous, outside materials that it literally has absolutely no way to digest. Just look at how abnormal metabolism physically transforms the architecture of this cell here. On one side, you've got a healthy cell, nucleus is clearly visible, clean cytoplasm, everything looks great. But then, metabolic failure kicks in, and the cell becomes totally engorged with fat droplets. The sheer volume of all this clutter forces the cell to change its shape entirely. It's quite literally bursting at the seams. Moving right along to Section 2, the sugar stockpile, carbohydrate accumulation. Any condition that messes with glucose or glycogen metabolism is going to lead to a massive stockpile of sugars inside the cell. When a patient has severe hyperglycemia, for instance, we see what's called glycogen infiltration. The excess sugar is just desperately packed away by the epithelial cells in the proximal convoluted tubules of the kidneys, in leukocytes, and in the liver. Alternatively, you can have genetic defects that cause glycogen storage diseases. In these cases, the breakdown process is broken right from birth, which can severely retard child growth. Now notice the microscopic evidence of enzyme failure right here. We're looking at glycosaminoglycans, which are complex carbohydrates normally eliminated by lysosomal enzymes. But in Gaucher disease, which is a really devastating lysosomal storage disorder, the patient lacks one single enzyme, glucocerebrosidase. Because that one microscopic scissor is missing, these sugars just build up relentlessly inside the cells, turning them into the swollen, highly dysfunctional husks you see here. It's wild how one missing piece causes so much chaos. All right, Section 3, twisted proteins, protein accumulations. So we have two very different scenarios playing out here. First, there's a structural, physical backup. Think of conditions like nephrotic syndrome, where there's a massive leakage of totally normal proteins, like albumin, into the kidney filtrate. The kidney cells frantically try to reabsorb it all, and they end up becoming physically choked in the process. On the flip side, we have a much more destructive mechanism, which is genetic protein misfolding. This is where abnormal folding leads to twisted, totally useless structures like tau proteins, accumulating directly inside our nerve cells. Look really closely at the proximal tubular epithelial cells in this kidney cross-section. See those small, homogeneous, kind of pinkish-red deposits? Those are hyaline droplets. This signifies proteinuria. It tells us, literally just by looking at the tissue, that there's increased protein filtration happening upstream. And these specific cells are physically choking on all those reabsorbed proteins.
Now compare those neat little kidney droplets to this. These darkly stained, elongated, totally twisted structures are neurofibrillary tangles inside nerve cells. This is that abnormal tau protein we mentioned just a minute ago, and this microscopic image connects directly to macroscopic devastation. The progressive loss of neuronal function caused by this specific type of cellular hoarding is actually a primary driver behind the cognitive decline and dementia we see in Alzheimer's disease.
And, the liver has its own version of protein tangles too, called Mallory bodies. These cytoplasmic inclusions in hepatocytes are made up of abnormal intermediate filaments, specifically keratin. Seeing them is an incredibly clear sign of severe liver distress, most commonly from alcoholic liver disease. Spotting these under the microscope tells a pathologist that the liver's cellular processes are deeply, deeply disrupted. It's a remarkably poor prognostic indicator for the patient, for sure.
Okay, Section 4, Fatal Fat Accumulations, Lipid Overload. This side-by-side comparison brilliantly reveals that macro to micro connection. On one side, you have a healthy, dark red liver and its cleanly organized microscopic cells. But then, introduce a toxic trigger, like chronic alcohol abuse or severe obesity, and look at the transformation. The entire organ grossly enlarges and turns this soft, greasy yellow color. And microscopically, the cells are entirely displaced by massive clear vacuoles of accumulated triglycerides. The cell has totally forgotten its actual job and just become nothing more than a fat storage unit. And hey, it's not just triglycerides, it's also cholesterol. Normally, cholesterol metabolism is really tightly regulated for synthesizing cell membranes. But when that regulation fails, cholesterol and its esters accumulate intracellularly, right within the walls of our arteries. This creates those deadly atherosclerotic plaques you see building up here, dangerously narrowing the vessel and setting the stage for a catastrophic cardiovascular event. But cholesterol hoarding doesn't just hide away in your arteries, it can actually push right through to the surface. When macrophages ingest massive amounts of intracellular cholesterol, they create these highly visible yellowish skin lesions called xanthomas. You'll often see them on the hands or Achilles tendons. Look at the tissue beneath those bumps. It's literally armies of cholesterol-laden macrophages. It's absolute proof that microscopic cellular traffic jams can and do create highly visible macroscopic symptoms.
Section 5, The Color of Disease, Pigment Accumulations.
Okay, let's dive into this colorful taxonomy. Pigments can be endogenous, meaning they originate from inside the body, or exogenous, meaning they come from the outside. Melanin naturally gives a brown-black color. Lipofuscin is this really fascinating golden brown pigment that naturally accumulates simply as a sign of cellular aging, kind of like wear and tear pigment. Hemosiderin, which comes from the breakdown of hemoglobin, shows up as golden yellow granules. And then we have carbon from inhaled pollution, which turns tissues black in a condition known as anthracosis. Now, when pigment accumulation runs completely out of control, the systemic damage is staggering. Take hemochromatosis, for example. It's a generalized cellular accumulation of iron-rich hemosiderin. It's actually often called bronze diabetes because the iron hoarding causes the skin to turn this slate gray color, destroys the pancreas, causing diabetes, and wrecks the liver, causing cirrhosis. Similarly, Wilson's disease happens when the body uncontrollably hoards trace copper. This toxic copper-brown pigment damages the basal ganglia in the brain, creates these visible Kaiser-Fleischer rings in the eyes, and simultaneously drives severe liver hepatitis.
Finally, Section 6, The Big Picture, Micro to Macro Impact. So while the medical names we've discussed today, things like Gaucher disease, atherosclerosis, or Wilson's disease, while they sound incredibly complex and totally unrelated, the root cause across all of them is fundamentally exactly the same. It's a microscopic cellular hoarding problem. Whether it's a lack of an enzyme, some abnormal metabolism, or twisted proteins, macroscopic disease almost always starts with a single cell that loses its perfect balance and just forgets how to clear out its own internal clutter.
So I want to leave you with this thought. We know that genetics play a massive role in things like enzyme deficiencies and protein misfolding. We can't change that. But we also clearly saw today that toxins like alcohol and massive influxes of excess sugar are huge primary drivers for forcing otherwise healthy cells to stockpile fat and glycogen. Knowing what you know now about how quickly a perfectly good cell turns into a panicked hoarder under pressure, what microscopic clutter are your lifestyle choices building inside your own cellular factories right now? Thanks so much for joining me for this explainer, and keep learning.